Hello and welcome to everybody on Cloud Fitness. So in today's video, we are going to see how we can use SVM kernels when we have an unbalanced data set. So whenever the data set is unbalanced, how we can use SVM kernel for separating the classes. Now this is just an example. You can use multiple ways to do that. And you can use your own permutation and combination to get through such kind of an unbalanced data set. So let's move ahead, but before moving ahead, do remember to subscribe to my channel and also connect with me on LinkedIn and Instagram, where I will leave the link in the description box. So let's move ahead and see exactly how this SVM can help us even in the case of unbalanced data set, or how we can actually use an SVM in case of unbalanced data set. So you can see that in command number 1, right here. Essentially, I'm just importing few libraries. You can see PyPlot for plotting. I'm using SVM, so I have imported SVM just like my previous videos. I'm using the data sets, right? And similarly, I'm using inspection to display the decision boundaries, right? So let me simply run this command, and after that in the command 2, what I'm trying to do is nothing but I'm trying to generate the data set. Right, so this is nothing but the data set generation. Now what is my data set? I'm using make blobs over here. I'm providing a sample of 1000 records and 100 records, and I'm trying to create a cluster of numbers, right? And this cluster of number looks like this. So if you can see over here, in this particular display, in this particular visuals, right, how my data set is plotted. So this is nothing, this is exactly the data set I am trying to create at the top, which is nothing but creating multiple cluster of values. Right now you can see there's a lot of unbalanced data set. It is pretty much one has more than 1000, right? In one data set I have provided 1000 values, and in one I have just provided 100 values, right? So this red ones are nothing but 100 values, these blue ones are 1000 values, and you can see a lot of overlapping. Now if we have to segregate these two, if I have to create a hyperplane over here, how do I do that? Now let's move ahead, and you can see this is how my data set looks like, but eventually you have already seen it using the visual, so I think that is the better form. So now you can actually see in command 5 what I'm trying to do, svm.svc. So I'm using support vector machines, right? I'm using svc. Here I'm saying the kernel is linear. Now remember that I'm using linear svm over here to create the decision boundary, and here hyperparameter I have provided the value as 1. This is the regularization parameter. Now I am running this, and you will actually see the CLF, this particular model gets created, right? This is a simple linear SVM kernel model where C, the value of the hyperparameter is 1. Now similarly, now since this is an unbalanced data set, right, it is an unbalanced, so one particular value has just 100 rows and one particular value has 1000 rows. Now how do we create the hyperplane over here? Now you can actually see that there is something called as class weight. So I have a class A which is I have a class A which is red, and class B which is blue. So now I am saying svm.svc kernel is linear, class weight is 1:10, right? 1:10. Now what does this mean, right? It means, and then I'm training my model. Now let me run this as well. Now this is, there are two values over here, right? You can see here I've just said that my class weight is 1:10. So what does it mean? It means that my first class is 10 times more important than my second class. So that is what is the meaning of this class weight. So you are saying that how much importance does my class A hold? So if you see at the top, I have 100 values, right? I have 1000 values over here, I have 100 values over here. So this is a very much unbalanced data set. Now here I'm just saying that my class 1 is 10 times more important than my class 2, right? And then what I'm trying to do over here, now I have two models, okay? Now you can see the CLF, right? The CLF is the one where I have not defined that my class is important. I have just said that, okay, give me a y is equals to mx plus 3, give me a hyperplane, right? Give me a hyper boundary, right? So here I'm using the decision boundary that I have imported at the top, and I am creating the scatter plot over here, and I am giving my model CLF that I have created at the top, right? And then these are nothing but these are simply my visual parameters that I have passed, and I have run this, right? Now similarly you can also see that this is how it looks like. This is how it looks like. You can actually see this is my hyperplane. It is, since it is 2D, I will actually call it as decision boundary. The how my decision boundary has come over here. Now the same thing, right? Now this part is exactly same. Now same thing if I do with WCLF, the second model that I created, where I have given the weighted classes, right? If I do it this way and I run this particular cell, you will actually see this is how my decision boundary gets created. So you can see the black one is nothing, the one which got created previously. This red one is the new one. Right now you can see the red one looks better than a better classifier than the black one in terms of the false negatives that you might get for the red values. Right now if you see, the red line will give you better accuracy for the red dots, but it might not give you better accuracy for the blue dots. However, without weighted, without keeping those weights, what will happen? Without keeping the class weight, you will get this black line, right, which is not going to give you correct accuracy for these red dots, this particular data set, and in fact it is not even going to give you good results for the blue as well. But now here you have to decide. Over here you have to decide what kind of, how much error, how many false negatives you can have for a particular class, right? How much precision you can actually, how much precision you want, how much recall you want. So that is something that you need to decide using these boundaries. But I hope you understood that how we can use these weighted classes to make sure that whenever we have unbiased data set, unbalanced data set, whenever we have unbalanced data set, how we can actually use these class weights as well. So I hope you like this particular video. Do remember to subscribe to my channel and like this particular video, and thank you so much for being till here.